Hi, I'm Robert Kollman. I'm a Senior Applications Manager at Texas Instruments. Welcome to Power Tips. Welcome to Power Tip 5. In this Power Tip, we'll show how to make a buck boost using a buck controller. We picked an integrated control IC to show this off, but almost any buck controller can be used to do this. And basically, if you look at the connections on a buck boost, you'll see that they're very similar to a buck regulator. What we have over here on the left is input voltage. It feeds a power switch that in turn feeds an inductor and rectifier. And so the way this circuit works is you turn your power switch on, it builds up energy in the inductor, you turn the power switch off, and the energy gets discharged from the inductor through the rectifier here into the output filter capacitor. And so if I hadn't drawn grounds on this particular schematic, you wouldn't be able to say whether this was a buck or a buck boost controller, because you see that the power switch and the inductor are connected in series like they are, and then they feed an output filter inductor and output filter capacitor. So it looks real similar to a buck regulator, but it's not. I mean, the nice thing about this, this takes a positive input voltage and gives you a negative output voltage. Also, if you start looking at the stresses in the circuit, you'll find that the stresses aren't the same as the buck regulator either. The inductor current is actually the input plus output current rather than just the output current. The switch sees the input voltage plus the output voltage rather than just the input voltage. And then if you look at the current in the output filter capacitor, it's discontinuous versus very low value of AC current that you see in a buck regulator. And kind of as an aside, the way this circuit gets started up is your input voltage is applied to your controller through the diode here. And so once the circuit gets up and running, the output voltage goes negative and generates a bias for the control circuitry. I have shown an example of a buck controller that you might use to do this. And this is a simple 3.5 to 60 volt input Swift. It's an integrated MOSFET. It has no synchronous rectifier on the output, so it's non-synchronous. This could be used, for instance, if you're going to make a 12 volt input to minus 12 volt output. And since the current's relatively high, you can do a fair amount of power with this. For instance, in this 12 to 12 volt example, we could get by with a 1 amp output current because the part's rated for 2.5 amps. Here we've shown another one of the family connected as the buck boost. This is a 54060, and in this case we're doing a 24 volt input to minus 12 volt output. Now, kind of as an aside, there's a lot of design collateral at TI that goes along with these circuits. The schematic appears in the application note that's noted here. We also have an Excel spreadsheet that lets you work through some of the stresses in the circuit and look at some of the power losses within the circuit. So the other point to make on this slide is that you can contact the factory for a evaluation module of this particular design. So thank you for your attention on this power tip. There are a lot more power tips that are available online. You can look on the EE Times website and search on power tips. You can look at the TI website and click on the link at the description section of this video and find a bunch more. Thank you for your attention.